You know, we are absolutely surrounded by technology. It's everywhere. The phone in our pocket, the computer on our desk. But have you ever stopped to think about what's actually making it all work? Well, today we're going to do just that. We're going to pop the hood and take a look inside.
Okay, so this setup right here, we all know it. It's a fixture in our homes, our offices, our lives, really. We use it for pretty much everything. But for most of us, that main tower, that digital box, it's a total black box, a mystery.
So have you ever actually wondered what kind of magic is happening in there that lets you watch this, or fire off an email, or get lost in a game? Well, that's what we're here for. We're taking a quick trip inside that box to pull back the curtain on how a computer really works.
So here's our game plan. First, we'll talk about the two fundamental halves of any computer. Then we'll meet the core team of components doing all the work inside. After that, we'll get to know the ghost in the machine, the software, figure out how we talk to our computers, and finally, see how this all connects to the tech we use every day.
All right, so the very first thing to get your head around is that every single computer is really made of two totally different parts: the physical stuff you can kick and the non-physical instructions you can't. Let's break that down.
First up, we've got hardware. This is everything, and I mean everything, that you can physically touch. Your screen, your keyboard, the mouse, and yeah, all those little chips and wires tucked away inside the case. Simple rule: if you can stub your toe on it, it's hardware.
And on the flip side, you've got software. Think of software as all the instructions, the programs, the apps, the operating system that tell the hardware what to do. You can't touch software, but you see its effects every time you look at your screen.
Now, this is where it gets really cool, and this analogy just nails it. The hardware is like the stage, and the software is the play being performed on it. One gives the other a place to exist, and the other gives the first one a purpose. You need both. A computer with just one is basically a paperweight.
Okay, let's get to the fun part. It's time to crack open that case and meet the core team, the main internal hardware components that are doing all the heavy lifting.
This right here is our map for the inside. I want you to think of it like an office building, and all the components are specialists working together on the main floor, which is a big circuit board called the motherboard. So let's meet a couple of the key players.
And here's the big boss, the Central Processing Unit, or CPU. This thing is the literal brain of the entire operation. Every single command, from both software and hardware, funnels through the CPU, which then executes it by making billions of calculations every single second. It's the heart of everything.
Next up is RAM, which stands for Random Access Memory. Now, the easiest way to think about RAM is to picture it as the computer's short-term memory, or maybe a workbench. It's where the computer puts all the programs and files you're actively using right now. It's super fast, which is great, but it has one catch: it's volatile. That means when you turn the power off, the workbench gets wiped completely clean.
And this is what RAM actually looks like. These little sticks. The more of these you have, the bigger your computer's workbench is, which means you can multitask and run more programs at once without things slowing to a crawl. That's why adding more RAM is one of the most common ways to give an old computer a little boost.
Then you've got its cousin, ROM, or read-only memory. Unlike RAM, ROM is permanent. It's non-volatile. Its one big job is to hold the super basic instructions for starting up, called the BIOS. Think of it as the computer's instinct. It's what tells it how to wake up and get going when you hit that power button.
So let's just boil it down. RAM is your temporary, super fast, constantly changing workspace. ROM is the permanent, read-only instruction manual the computer uses just to get started. See the difference? One is for doing, the other is for started.
So we've met the hardware team, but a team of experts with no instructions, well, they're not going to get much done. And that's where software comes in. It's the ghost in the machine that brings all that hardware to life.
Now, software usually comes in two main flavors. On one side, you have system software. Your operating system, like Windows or Mac OS, is the perfect example. It's the director of the whole show, managing all the hardware and telling it what to do. Then on the other side, you have application software. These are the programs you actually use every day. Your web browser, your spreadsheet program, your favorite game, they're the tools, and the operating system is the workshop they live in.
So we've got the hardware and we've got the software. But how do we fit into this? How do we humans actually tell the computer what we want it to do? Well, for that, we need a translator, something called a user interface.
And this comparison just says it all. On the left is the old school way, the command line interface, or CLI.
You had to know the language and type precise commands to get anything done. On the right is what we all use now, the graphical user interface, or GUI, where we just point and click on little pictures and windows.
And there's a pretty clear trade-off, right? The command line is incredibly powerful and direct, but you have to be a bit of a nerd to use it. A GUI is way more intuitive and friendly for everyone, but all those pretty icons and animations use up a lot more of the computer's resources, like its memory and processing power.
Okay, so now we know the basic ingredients: hardware, software, CPU, RAM, and an interface to talk to it all. So let's take a quick look at how these same building blocks show up in all the different computers in our world.
First, you've got the classic desktop. Because there's so much space inside that big case, these are often the most powerful machines, and they're way easier to upgrade or fix. The obvious downside? Yeah, you're probably not going to haul it down to your local coffee shop.
And then there's the laptop. This thing is a true marvel of engineering. It takes that entire core team, the brain, the workbench, the storage, the screen, and shrinks it all down into one package you can carry around. You might trade a little bit of raw power, but what you gain in mobility is a total game changer.
And what about this little device? Don't ever forget, your smartphone is a full-on computer. It has a CPU, it has RAM, it has storage, and it runs a complex operating system with tons of apps. It's just been shrunk down to an almost unbelievable degree. A supercomputer that fits in the palm of your hand.
Desktops, laptops, phones, they're all built on the same core ideas we just covered. But you know, technology never stops moving. The next big step isn't just about making the hardware smaller or faster. It's about changing the software, that ghost in the machine, so it can start to learn and make decisions on its own. Of course, we're talking about artificial intelligence.
So here's the final thought I want to leave you with. For decades, we've been the ones writing the story that the software tells. But we are now building machines that can start writing their own stories. It's an incredible, maybe even a little scary future. And it's all built on the foundation of that simple digital box we just explored together. Thanks for joining me.